is Math 6 for Wednesday, April 8th, and we are on lesson 109 on page 262 in your text. And today we're going to continue on talking about proportions. Today we're going to be comparing some shapes though. And the word that you need to be listening for to make sure that you can do this proportion problem is that the shapes are similar. Now, if you remember, shapes that are similar are the same shape, different sizes, but they have to be the exact same shape, okay? So these shapes I could do proportions for. I could not do proportions for these shapes. Although they are both triangles, they are not similar, okay? So we can only do proportions when we have similar shapes. Okay, with that being said, let's look at those two rectangles. Okay, so in 10 centimeters, and then our similar shape says 6 centimeters, and this side is 4 centimeters. Okay, and it wants to know, well, what is in? Well, if I know that they're similar, I can set up a proportion and solve it, just like I did yesterday. I can say 10 is to 4, because they're both the shorter side. So 10 is to 4 as n is to 6. Now notice how I worked across. If I start with a left number and then go to right, I need to do that the same for the second one. I wouldn't want to say 6 is to n, would I? So 10 is to 4 as n is to 6. Okay, so now that this proportion is set up, I'm going to go ahead and reduce to make this a little bit easier. And then I'm going to cross multiply and say that 2 times n equals 5 times 6, which is 30. And then 2 times what equals 30? Or 30 divided by 2. So n equals 15. Now, I need to make sure I'm using my measurements in my answer. 15 what? 15 centimeters. Okay. All right. Notice in the second problem they have the same thing. In this problem they just set up the proportion a little bit different. So remember how I said little is to little as big is to big. This one they went, this shape is 10 is to n, little is to big, as little is to big. And they said 10 over n equals 4 over 6. Okay? That is the same exact problem as this one. Notice that you have 4 and n multiplied together and 10 and 6. As long as you keep your proportions straight, whatever you do for one, you do for the other, and you keep them organized, you're going to end up getting the same problem and therefore getting the same answer. Miss Henry's class wanted to know the height of the flagpole in the schoolyard. Although the flagpole was too tall for them to measure, Miss Henry showed the class how to use lengths of the shadows to figure the height of the flagpole. Okay, so if you look at our picture, so what she did is they had the flag out there, which cast a shadow, right, something like this. And she said, okay, well, let's think about this shape here. This height compared to the shadow. And let me bring out my meter stick, I believe is what she used. And she stood there with her meter stick and she said, well, I have 1 meter stick and it cast this shadow. But the shadow it cast is 1.5 meters. Okay, so now you can see our similar shapes. Then because this shadow is on the ground, they were able to measure it and see that it was 7.5 meters long, this shadow. And so now we have a comparison that we can do. We can say the flagpole, which we can label n, a number we don't know, n is to 1. The flagpole is to the meter stick as the shadow of the flag is to the shadow of the meter stick. Okay? And here we're dealing with some decimals, but we can solve it just the same. We can say 1 times 7.5 is 7.5 equals 1.5 times n. What's the opposite of multiplication? Division. So we need to do 7.5 divided by 1.5. Okay? And we can do that calculation. Let me remind you how to do that. 7.5 divided by 1.5. I can't have a decimal in my problem here, so I need to move it over 1. So I move this one over 1. So here's my decimal point. How many times can 15 then go into 75? I hope you're thinking about 5 times. You might have to work that out. 5 times 5 is 25. 5, 6, 7, so 75. So my answer is 5. So n equals 5 what? What were we measuring in? Meters. Okay, so my flagpole is 5 meters, and I was able to figure that whole problem out without actually measuring the flagpole. It's a really neat way to measure. Okay, so today you're going to do numbers 1 through 8. Be very careful setting up those proportions, and if you need help, please don't hesitate to Marco Polo me.